Welcome to the deep dive. So you've sent us right into the deep end of signal conversion this time. The sources are all about this Thor Broadcast H-THUNDER-4, a 4-channel digital RF encoder modulator. Our mission today is to figure out what this thing actually does, how it pulls off being, globally compatible, and really why it's still such a critical piece of tech.
It's a fascinating bit of kit. It really is. We're going to unpack how this one box can handle, well, pretty much any TV standard on the planet.
Right. But before we get into the weeds on the tech, there's something kind of funny in the source material. The word Coax is everywhere. HDCO, AX8, over Coax or IP, it's all over the place.
And this is what I love about technical documentation. It's so absurdly specific, and yet it tells you everything about signal integrity and bandwidth, but absolutely nothing on phonetics. You can read for hours. There is no guide on whether you should say Coax, coax, or the big one if it's supposed to sound like Coax.
A critical piece of information, completely missing. Okay, so with that mystery unsolved, let's get into the H-THUNDER-4 itself. How do we even start to explain what this box does?
I think the best way to think about it is, it's like your own personal TV broadcast station, a tiny one. So imagine you're running a hospital or a big apartment building. This device is your central tower. It takes in up to 4 different HDMI sources. It could be a satellite box, a camera feed, anything. And it prepares them.
Prepares them for what exactly?
For any regular TV to just pick it up, like a normal cable channel. The key action here is the encoding and modulation.
Oh, okay.
It uses MPEG-2 encoding and then modulates that signal into, a whole bunch of different RF outputs, DBC, ATSC, all those acronyms. But the real insight isn't just that it converts it, it's how it handles the messy reality of global broadcasting.
And that's the part you really focused on, the global plug-and-play aspect. What's the actual engineering challenge it's solving?
The challenge is that TV signals are completely different depending on where you are in the world. So ATC is what we use in North America. Europe and Australia mostly use DVB-T. Then you have Japan and South America using ISDBT. They're all fundamentally incompatible.
Different standards, different hardware needed?
Usually, yes. But the H-THUNDER-4 comes with every single one of those standards built in, and it can switch between them dynamically.
Yeah.
So one box, one single model can be sent anywhere in the world, and it just works. It's a huge deal for inventory management.
That's incredible. And I'm seeing the specs here. It handles 4 HDMI channels, full HD at 1080p 60, and the latency is quite low, 5200 milliseconds. But you mentioned MPEG-2 encoding. Isn't that a bit old? Are we losing something for that compatibility?
That is a critical trade-off, you're right. MPEG-2 is older, less efficient than modern codecs. But it's also universally understood by pretty much any TV made in the last 20 years. So you're trading efficiency for maximum compatibility. And the management system, the web interface, or the front panel, that's what's doing the heavy lifting to keep it all straight.
Got it. So let's talk about where it sits in the market. The sources mention HDTV Supply has a partnership with Thor, and this H-THUNDER-4 is noted as being cheaper than some of their other product lines, like the H.264, HDMI, QAM, IPLL. What's the real difference there? What are you giving up for that lower price?
The key difference is the output. It's a really important distinction. This H-THUNDER-4, it puts out a KTV RF signal. That's it. It's for Coax cable systems only. The more expensive line adds IPTV output. So if you need to send your channels over a computer network, over IP, you have to upgrade.
So this is purely for localized RF-only distribution.
Exactly. For that specific job, it's perfect. The price is listed at $1,985. And it comes with a 2-year warranty, and it's TAA compliant, which is important for any government contracts.
Okay, so to wrap this all up for the listener, we've looked at this very specialized device. It's basically a powerful, localized broadcast engine that's somehow compatible with the entire world. It takes modern HDMI signals and turns them back into RF signals that any TV can understand.
And that really brings up a fascinating thought to leave you with. I mean, think about it. If a single piece of proprietary hardware like this can already merge all these conflicting global standards into one simple box, how much more integrated will broadcast tech become when IP finally, fully takes over from RF? The technology to unify it all is clearly already here, just on a smaller scale. The global networks have to be